everyone, or as in Australia we would say, good day. Nice to be here, and so I'm going to give a quick overview from Australia's perspective. I'm going to have a look at a few sites that we have in Australia that are doing different things. The most significant thing that's going on at the moment in terms of new supercomputers in Australia is actually our Bureau of Meteorology, which is getting new machinery, and I'll mention that in a moment. So just quickly to recap Australia in context, we have a huge area, a relatively small population, we're reasonably well off, quite wealthy, and so therefore we invest in things such as supercomputers and high-end data analytics machines and so on for our economy. We have a high standard of living. The thing I also want to highlight though is at the bottom, we're prone to harsh weather phenomena, and that comes into this Bureau of Meteorology machine. So at any moment in time we may be having in our summer season, which is the opposite of most people here's summer season, it's actually in January and February and so on. We could have tropical cyclones, we could have fires in our forests, we can have floods on a huge continent. It can be very, very difficult for us to deal with, and so that's why we've got a new supercomputer for our Bureau of Meteorology that's actually going into production in the next month or so. And it's not just actually the Bureau of Meteorology itself, it's the NCI, Lindsay Botton, the director at the back there, that a lot of the developments for actually be able to target specifically Australia are done in collaborations that happen at NCI. In terms of Australian HPC institutions, I just want to talk about a few of these. So we have two nationally funded centres, the NCI and Pawsey Supercomputing Centre. There are 3 other machines in the current top 500 list. CSIRO is our national science agency, and so that's not only investing in the 2 national centres, but also has its own machines. The University of Adelaide has a GPU cluster, and what was the first of our petascale systems? It wasn't quite a petaflop, but a petascale system in Melbourne at the Victorian Life Sciences Computation Initiative. There are a couple of other specialised facilities and research centres that I'm going to talk about because they're here at the conference. You may meet them, you may want to talk to them and see what sort of things they're doing. And so these particular 4 are here, but there's also University of New South Wales. Luke over here in the corner is also represented. So we're very friendly people. Come and talk to us, and we're quite happy to talk to you about what we do. So let's head off from Frankurt to Australia. So we'll begin in Melbourne. And Melbourne has announced back in March they had a new machine, something called Massive. Now, Massive's an interesting setup because it's not going to have massive core counts and huge flop counts, etc. This is about helping people do visualization, do some data analysis, do things interactively a lot of the time as well. And it's particularly got strategic focus on things such as neuroinformatics, molecular imaging, characterization, where there's a lot of data, there's a lot of images, for example. So the systems themselves aren't particularly big, but there's a lot of users, a lot of active projects that use this equipment, and they contribute to the national merit allocation schemes that we run as well. And significantly, the Australian synchrotron. So the Australian synchrotron is pretty much our most expensive and often talked about as our most significant piece of scientific research infrastructure. Generates quite a lot of data, it needs to be analysed somewhere, and so you put the machines quite close to where the data is generated. It's also underpinned this particular thing with Massive partnership with NVIDIA. So Singapore is the hub, I believe, for the NVIDIA collaboration in the Asia-Pacific region, and this is for the first spoke away from the hub. Particularly Wojtek, who's here at the conference, wanted to mention about neuroscience. So they're having a huge number of extra projects that are going on in neuroscience, and he'll be giving a talk later on at 12 noon. So from Melbourne, we move up to Brisbane, and in Brisbane, there's a machine called Flashlight, and it's a data-intensive platform, so it's quite a lot of memory, 512 gigabyte nodes. And so again, this is for data analytics rather than it is for simulation sciences, and that's a lot of what you'll see just in the next 2 or 3 slides, quite significant. From Brisbane, we head off to our capital, which was significant because that's why we actually are here presenting first. In the nation's capital, we have the National Computational Infrastructure. This is information I passed last year. It's about 60,000 core machines. It's got about 2,500 users, I believe, who are using the NCI facilities. And it's got our fastest file system, so there's a lot of file system access that can go on there. A lot of people these days are using burst buffers and other techniques, but this was before people were really getting involved in that area. So some of the science stories of significance there, climate and earth system science, in particular, as I mentioned already, helping develop our Bureau of Meteorology so they can develop those weather models, but also some climate work that's been fed back into the models that the UK Met Office work. Satellite Earth observation data are back. We're back to data. So this is being taken from the EU Sentinel data. There's also Copernicus. There's also data that's taken from the Himawari satellite as well because of the Bureau of Meteorology. Huge amounts of data, all needs to be analysed and looked at. And then genomics is another field. Again, it's a lot of data. Huge amounts of data from human clinical trials, about 5,000 people, from what Lindsay Botton was telling me yesterday. And so this is going to be a pretty big project, $25 million project over 5 years to be able to talk about translating this into advances in clinical practice. From Canberra, we head off to Perth, my hometown, in Western Australia. And the Pawsey Supercomputing Centre, we have two machines. We have Magnus, which is still the #1 machine in the Southern Hemisphere. It's falling down the list now. And this is designed for a general purpose machine, but we also have a machine called Galaxy, and this is one that I just mentioned on the next slide, particularly for work in radio astronomy and square kilometre array. It's data intensive, huge amounts of data coming down from a radio observatory. For example, we have about 250 terabytes per day are shipped down from the telescope. We turn that into about 15 terabytes of data products that will actually be used. So a lot of data processing going on. The significant thing is 10 petabytes of data that we actually keep and store after we've actually generated these data products. And this data is accessed by thousands of astronomers around the world. So this is actually part of the telescope. If this machine is down, particularly if the file system is down, you park the dishes of the telescopes and there's no observing going on. It's about 800 kilometers away. It's also quite significant because, so you're familiar with the gravitational wave discoveries, the discovery of the decade, so to speak. Well, the significant thing that happens when one of those gravitational waves is detected, LIGO doesn't really know quite where it is, and so they ask telescopes on the optical and in the radio to look in the general direction in the sky. These two particular telescopes are particularly significant there because they can do that very quickly. And they actually are very good at surveying large parts of the sky. The MWA, because it's just dipoles, can actually do this in seconds. And so they didn't find anything when they were actually looking, but they said it's fascinating to be actually involved in this, and they hope in the future to actually be able to see something that relates to the gravitational wave that was generated. And the other thing I want to talk about from the Pawsey Supercomputing side is this project where we're helping African farmers. Now, we all know that fantastic science goes on our machines. We're all saving the world in some way. This is a particularly significant thing. The cassava crop is the staple crop of about 800 million people worldwide, and it can be attacked by viruses that are carried by a whitefly. Previously, it was thought there was just one type of whitefly. Some phylogenetic analysis has detected there are actually 34 different types of whitefly. And if you can actually protect the cassava crop, if you can develop new strains, then you can actually make African farmers so they won't have to worry anymore about their crops getting devastated. This has actually been recognized by the United Nations. So every year in September, all the big world leaders get together and they have the United Nations Summit. They've now started something called the Solutions Summit, 17 sustainability goals, and they picked 14 out of 838 entries to who is really helping here, who is saving the world. And Laura Boykin was one of those, and it was great because the title itself, Supercomputing and Global Food Security. So we can all be proud of supercomputing saving the world. Thank you very much.